Okay, so welcome members. Let us see now how do we find the probabilities if you have a coin and maybe a tetrahedron, a coin and a die, or when you have a coin and a coin. Okay, but please don't forget to subscribe to the channel and press that red button there. Okay, so probability here you have if a fair die is thrown, find the probability that the outcome is part A an even number brackets E, an odd number brackets D, not an odd number. So let us see. First of all, we first generate the sample space. We know that a die is numbered, it has sides numbered from 1 up to 6. So we generate the sample space first. So meaning the solution here, our sample space is going to be, is first of all going to be 1, 2. Why? Because we know a die is numbered, its sides are numbered from 1 up to 6. So now we come to Roman numeral 1. Probability E, that is the even number is E. So probability of an even number is going to be, now you look how many even numbers we have. We have 1, 2, 3. So even numbers there are 3 over the total number, I mean the total outcome. You see 1, 2, 3, 4, 5, 6. So the outcome is 6. And you can reduce this to 1 over 2. So even numbers is that our even numbers are this one, and this one. They are 3 over the total, which is 6. You can reduce by 3. Then probability, the number is odd. So here even numbers we have are 2, 4, 6. What about odd numbers? Odd numbers we say is a number which when divided by 2 you get a remainder 1. So that we have only 3 and 5. So that means it's going to be 2 over these 2, the 3. So this one is odd and this one is odd. So it's that we have 2 over the total, which is 6, and we can reduce this to 1 over 3. So our odd numbers here we are 3 and 5. How simple as that? And you are done and you get all in maths. Pull not a probability, not an odd number. We say, now not an odd number, we say the probability of an odd number plus the probability of not being odd, the result is 1. So if we know the probability of being odd is, already from here, is a third. So this is a third. Then plus the probability of not being odd will be equal to 1. So it's that our probability, if we take this side, probability and the number is not odd, is going to be 1 minus a third, which is going to be 2 over 3. And I take this side. So that's how we do it. This one is probability, the number odd, and number not odd is equal to 1. That's how we summarize that with ease. Okay, let us come to this now. A coin and a fair die. Here they are throwing a coin and a die. At once, find the probability that a head appears with an even number, a tail appears with a prime number, a head appears with a number greater than 3. So we first generate the sample space there. So in our solution, our sample space, you see, we have a coin, this side, which is having a head and then a tail with ease. Then here, up, I'm going to put my die. So my die is going to be there. Let's number from 1, 2, 5, up to 6. Okay, so now you see that the outcomes, I can have a head, then a 1, a head and a 2, a head and a 3, then a head and a 6. Then I can be having a tail and a 1, a tail and a 2, a tail and a 3, a tail and a 4, a tail and 5, then a tail and 6. And so the sample space, so here my sample space is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's going to be 12. Okay. Then we come to the question. A head appears with an even number. So we want now remember one probability. A head appears and an even number. So we have say head and an even number. So we have this already. A head and even number. This is even number. This is a 2. We have a 4. A head and an even number. Also here, a head and an even number. So there are 3 where a head can appear with an even number. So 1, 2, 3. So the event for that to happen is 3 out of 1, 2, 3, 4. They are 12. And you can use these to quarter. Then a tail appears with a prime number. So remember 2 probability, a tail, and a prime number. If I call my P prime numbers and E even numbers. Okay. Now let us see a tail and a prime. A prime number, we say, is a number which has 2 factors, 1 and itself. So we have many prime numbers we have. But this time we want a tail and a prime number. So a tail and a prime number, first of all, the first prime number is 2. So this one qualifies automatically. 1 and itself. Also this one qualifies. Because 3 is also prime number. Then also a tail, and then a 5 is also prime number. So there we have 1, 2, 3. So we have 3 over 12. The total of all these events is 12. And this one is that's also going to be a quarter. Then Roman numeral 3, probability. A head appears with a number greater than 3. So you want a head and a number, comma, greater than 3. So a head, a number greater than 3. We see that a number greater than 3, we have a head, numbers greater than 3 are 4, 5, and 6. So we have 1, 2, 3. So those are the numbers. So there are 3 over the 12, which is also going to be a quarter. As simple as that. So, members, that's how we answer this one. Let us come to this one. 2 coins are thrown together. Find the probability that 2 heads appear, at least 1 tail, and at most 1 head. So first of all, the first element our sample space. We have 2 coins. The second is here. And let us put the first up here. The first coin. This one is having a head and a tail. Also this is a head and then a tail. So you see here, you can have a head and then a head, then a head and then the tail, then here a tail and a head, then a tail and a tail. So that's the sample space. So see that now there are how many? 1, 2, 3, 4. So the number of the sample, the possible events are 4. Let us now start answering the question. So probability, 2 heads. Is that 2 heads which we as H heads are given as H. You see, these are the ordinary cases. So it's 1 out of 4. So it's 1, this is the ordinary case where we have 2 heads. So it's 1 over the total 1, 2, 3, 4. As simple as that, I mean that one is already listed. Remember 2, at least 1 tail. We say at least 1 means from 1 up from 1, at least 1 means from 1 or 2. Because with the ordinary case, we can only have 2 tails, we can't go beyond 2. That's why I'm stopping at 2. If we had maybe there's a case for 3, we would go for a 3. But that is the case we have. So, probability at least 1 tail. So at least 1 tail, you see, this one you have already 1 tail there. Here we have also one tail. Here and here we have two. So at least you can have one or two. So you see that now we have here tail, and here tail. So these are 1, 2, 3. So you have 3. They're all over 4. Roman numeral 3, they are telling us that at most one head. At most one head. Okay, at most means one is the greatest you can have. Also 0. At most one. So here we have one head at least. At most one. So the greatest you can have is 1. So we have this one head here one head, and here there are 0 heads. So from 1 you can be having 1 head. At most means 1 or 0. But here I can't take this because here we have 2. But we said at most 1 means the highest you can have is 1. So it's that they are going to be 1, 2, 3. Also they are 3 over 4. And those are the solutions, members. So that's how you can handle that, members. I wish you the best.